Okay, good morning everyone. So today we are going to start with our next topic, and that is about unit step response. Unit step response means the output of the circuit if the input is a unit step function. Okay, so step response of a circuit is the behavior when excitation function or excitation means the external force, okay, is a step function. It can be a voltage or current source, anything. Now consider this. You have Vs, R, switch, C. This switch is open before t equal to 0. Though if switch is open, that means circuit is incomplete. So the current flowing in the capacitor will not be there. Nothing, no current will flow. Okay. And the voltage across resistor is Vs, and no current is flowing, no voltage is developed across the capacitor. Fine. Now we are saying at t equal to 0, the switch will be down. So when this will be down, some current will start flowing and capacitor will start charging. When it is fully charged, the current will stop. The same circuit, instead of showing like this, can be shown like this. That means Vs ut. Ut is making sure that before t equal to 0, the input is 0 volt, and after t equal to 0, the input is Vs volt. Okay. Now we are saying we have to analyze this type of circuit. So first of all, we should know that voltage across capacitor will not change abruptly. So whatever is the value at t equal to 0 minus, same will be the value at t equal to 0 plus. And that is the initial value stored across capacitor V naught. Now look at this. If I apply KCL at this node, what is the outgoing current in this branch? That is V minus Vs upon R. V minus Vs upon R. And what is the current in this branch? I is equal to C dV by dt. C dV by dt plus V minus Vs by R equal to 0. This is my KCL equation. Then I write this equation. I just separate V minus Vs by R as V on this side, Vs on this side, and here was C. I divided everything by C. After that, we have to just play with these equation, and we are saying because I am analyzing for t greater than 0, there is no need to write ut because ut is 1. Okay, so this is my equation. Now what I will do, I will bring this V also on this side. So this becomes minus of V minus Vs by Rc. Now what I will do, I will bring these two on this side. So dV by V minus Vs is equal to minus dt by Rc. Then we take integration. So we get natural log of V minus Vs, Vt and V naught are the limits, is equal to minus t by Rc. T and 0 are the limits. So natural log V minus this Vt will replace V. So Vt minus Vs and V naught minus Vs. This is the second limit, is equal to, when you put t equal to t, t by Rc, and when you put t equal to 0, 0 by Rc. Okay. Now left hand side, this is natural log of term number 1 minus natural log of term number 2. That means natural log of term number 1 by 2 is equal to minus t by Rc. Take exponential. V minus Vs upon V naught minus Vs is e raised to power minus t by tau, where tau is equal to Rc. So V minus Vs is equal to V naught. This term goes here, and then I shift this Vs also this side, and this is my equation. Is there any problem in this derivation what we have done? You can go through again when you will be having the slides, but eventually what we are able to do, we have the equation for voltage across capacitor. Hello. Hanji. Yes. उसको बोलिए रिफ्रेश करे F5 बटन, नहीं तो कंट्रोल और डिलीट से वाईफाई चेक करे, फिर से रिफ्रेश करे, और कुछ नहीं होता है तो पीसी रीस्टार्ट करे। तो कंट्रोल ऑल्ट डिलीट से वाईफाई चेक करें या वाईफाई को चेंज करें, फिर से रिफ्रेश करके देखें, नहीं तो कंप्यूटर रिस्टार्ट करें। Okay, so now what is the equation of voltage across capacitor that we got? That is Vs. Vs is the external voltage source that we have applied in this circuit, plus V naught. V naught is the initial voltage across capacitor, minus Vs e raised to power minus t by tau. Once I get voltage across capacitor, the remaining quantities can be calculated by voltage distribution, current distribution, or any other thing. Okay. Now, if I have the equation of V of t, what will be the current in capacitor? That will be C dV by dt. And if you differentiate this term, you will get the current in capacitor also. So this is voltage in the capacitor for t less than 0, t greater than 0. And we are saying initially if V naught is equal to 0, then it is 0, and Vs minus Vs upon, so this thing is Vs into 1 minus e raised to power minus t by tau. So we got this. Okay. Now coming to the current, current is C dV by dt. You differentiate it and you get current also. So voltage across capacitor, current in capacitor, voltage across resistor, all these things you can calculate now. Now we are saying every time do we have to do the same thing? We say no. If we look at this quantity again, let me show you something. This is the capacitor which we have. Okay. Okay, consider this circuit. What will be the final value of V? Anyone can tell me? What will be the highest value that will appear across V?
Vs
Vs, right?
of the source.
Yes.
That will be Vs. When this capacitor will be fully charged, this V will be equal to Vs. Okay. When this is equal to Vs, how much current will flow in this branch?
Sir, zero. No.
Zero.
Zero.
Okay.
Zero.
I will be 0. So what will be the drop across resistor?
Zero.
Zero.
0.
Zero.
Zero.
Okay. Now tell me what is the initial value of voltage across capacitor? That was 0 or V naught, right?
Yes, sir.
So we are saying if you look at this equation which we just got here, this one, I can say that I can calculate my complete equation of voltage across capacitor as V final. Finally, it is giving me the value Vs, right? V final plus V initial minus V final into e raised to power minus t by tau. So all you need to calculate is what is the initial voltage across capacitor, what is the final voltage across capacitor, and time constant. Is that okay? And then you write that voltage across capacitor will be V final plus V initial minus V final into e raised to power minus t by tau. Okay. Now let
Sir?
Yes.
So may you please explain why final voltage will be Vs? Won't be Vs minus voltage drop across
Can you
resistor?
can you explain the last part once more, sir?
No, no, we are coming to that. First, you were asking why the voltage across capacitor will be Vs.
I thought it would be Vs minus voltage drop across resistor.
Yes, and eventually that drop across resistance will be zero. So it will be Vs minus zero equal to Vs.
I'm asking of final.
Final only. Eventually means final. Finally, what will happen when the capacitor will be fully charged? What will be the current in capacitor? If the capacitor is fully charged, that means voltage across capacitor is constant.
Yes, sir.
Voltage is constant. That means I is equal to C dV by dt. So current is zero.
Okay, sir.
If the current is zero, that means current in resistor is also zero.
Yes, sir.
Okay.
Sir,
Yes.
sir, can you please go to the previous slide?
Okay.
Yes, sir. This one. No, no, sir. The next one. Another next. Yes, sir. This one. Vt when t is less than zero, it's v naught. So it should be v naught e raised to power minus t by tau.
Why?
So because vs will become zero when it is less than zero.
Okay. So come here. Vs is zero. Vs is zero. Okay.
Yes.
So if you supply zero voltage to a circuit for a very long time, we are talking from minus infinity to zero. What will be the voltage across capacitor then? It will be zero, right? It is not charged. No, you are not providing any voltage source. So how can you have some voltage across any of the element?
So, sir, what is that v naught?
We will come to that. We are saying, let us assume initially the capacitor was charged. Okay, then it is V naught.
So, sir, so that should be v naught into e raised to power minus t by tau.
Why
I
it
mean, if
should be
there
T
is
by
if
tau?
if from minus infinity to zero there is no current, so that this capacitor will
Okay,
discharge.
okay. Let me frame. Oh, we will come to this question later, but let me tell you. I am saying this voltage source is 5 volt for a long time, and at t equal to 10, t equal to 0, I am making it 10 volt. Now
Okay,
tell me at t equal to 0, what is the voltage across capacitor? It is 5 volt or 5 into e raised to power minus t by tau.
5.
5, right? That is V
Yes.
naught.
Okay.
And when you change 5 to 10, then it will slowly shift from 5 to 10, right? That is what
Yes.
we have shown in this figure. See, this figure. Initially, it is V naught for a long time. And then I'm changing V naught to Vs. It will slowly change to Vs. Okay?
Okay.
Right. Now look at this. What are we saying here? This part of the response is earlier also we studied. It is called natural response. And final value is called V final. Okay. So we are saying that the total response is V forced. Vf means V forced or final value plus V natural. Final value, you consider DC circuit and calculate what will be the final value across your capacitor and natural response. Okay. If you add both of them, finally we say that voltage across capacitor at any given time is V final plus V initial minus V final into e raised to power minus t by tau. So I need to calculate three things: V initial, V final, and time constant. Is this okay? Now let us have a question on this. I have this question. We are saying there are two voltage sources, one is 24, one is 30. The switch is in position A for a long time. At t equal to 0, I am moving my switch to position B. Find the equation of Vt for t greater than 0. And after that, you can calculate what is the value of t, what is the value of voltage at t equal to 1 or 4 seconds. So this is the situation of my circuit for a long time. When I say this is the situation of my circuit for a long time, that means DC conditions are prevailing. Under DC condition, capacitor will act like open circuit. Okay. So what will be the voltage across capacitor at t equal to 0 minus?
Voltage across 5 kilovolts.
Voltage across 5 kilo ohm, and how much will that be?
15.
15.
15 volt. Okay, this is my initial value. You can also call it and this will also be your VC at 0 plus, and or you can call it V naught. Is this okay? Now after that, what we are doing, we are shifting this switch here. This is disconnected, all these are gone. Now this is one RC circuit which will try to charge or discharge the capacitor, plus there is a external voltage source 30 volt. Now if this arrangement goes for a long time, what will be the final voltage across capacitor?
30.
That
45.
will be 30. Okay, if you are attaching 30 volt, it will bring it to maximum 30 volt, right? And what is the time constant?
Sir, 2.
Time constant is RC, where R is 4K and C is 0.5 milli, that means 2. So what is my equation of VT? V final plus V initial minus V final into e raised to power minus t by tau. Is this okay?
Yes, sir.
Anyone having any issue with this?
Sir, V initial 15.
Yes.
Sir, how is V initial 15?
V initial is 15 because initially the capacitor is attached on this part of the circuit. Okay, capacitor is attached to this circuit for a very long time. Consider DC conditions. In those DC conditions, when this capacitor is open circuit,
इडली
the,
सांभर बना लो ना
the voltage across this capacitor is
No.
same as, okay, please
आराम से
switch off the
बनेगा
mic.
आराम से बनेगा आप
Okay,
आप
everyone.
मुझसे कह रहे थे जब मैं आऊंगा तब बनाना मेरे आइडियाज देखो कितने अच्छे हैं एकदम से याद आया
Okay, now the mic is off or not? Okay, fine.
Off, sir.
Right, so we are saying when this is the first part of the circuit, the voltage across this capacitor is same as voltage across 5 kilo ohm. That means 24 volt is divided between 3 and 5 kilo ohm, so that is 15. So voltage across capacitor is 15 volt. Is this okay?
Yes, sir. Thank you.
After that, we are saying now the capacitor is attached with this combination, that means these, and it will also remain for a long time. Finally, what will be the voltage across capacitor? That will be 30. Okay. Now everyone calculate the second part of this question. That means what is the value of Vt at t equal to 1 and 4 seconds? Calculate those answers.
Excuse
And
me, sir.
yes.
Sir, we are totally considering ideal situation, sir. I think, sir, there will be some resistance offered by 4 kilo ohm while charging of capacitor, sir.
Why do you want to complicate your life if it is going smooth? This is the first course in circuit analysis. You will have those complications later.
Okay.
Okay.
Yes, sir.
So now calculate what is the value of Vt at t equal to 1 second and 4 seconds. Calculate those answers in at least 2 or 3 decimal points. You should have a scientific calculator with you. It will be used in a lot of courses. If you have not purchased, please purchase one scientific calculator. You will be allowed to use calculators in the exams and quizzes. Okay.
Sir, can you suggest some model of the calculators?
Nothing like that. Mostly like Casio or anything like we, as being the electronic component side, we don't need any graphical kind of calculators. There are some calculators which will have graphs, functions and all. You don't need those things. A normal scientific calculator with just a decimal number display, that should be fine. I think some 900 series is coming with Casio. That is what most of the student uses.
Yes, sir, 991 ms.
Yes.
Okay.
So
Sir, 20.87 and minus 79.35.
how can it be minus? Capacitor voltage is going from 15 volt to 30 volt. In between it will go minus. These are the things you should realize while obtaining the answers. Some of the things are like cross-check points. Oh, both your answers, what is happening to the capacitor? It is slowly going from 15 volt to 30 volt. That means both the answer should be between 15 and 30. And the answer at t equal to 1 should be more closer to 15, and the answer at t equal to 4 should be more closer to 30.
Yes,
This
sir.
is how you will, right?
27.94 at t is equals to 4
Right. So
seconds.
these are the answers you can cross check, those who have obtained. Okay. Right. So if you have done that, all of you start cross checking this also. Those who have not done, they continue the previous one. Those who have done, they start solving this one and check if you are getting it correct. So when we consider this circuit, again we say we will focus on three things: V initial, V final, and the tau. What is the value of V initial? Anyone who can tell me?
10.
10.
10. Okay. So I
10.
put it V0, that is 10 volt. What is the value of V final?
Minus 5.
Minus 50. How do you get that?
40.
Sir, there will be no current in the capacitor branch, so
So first of all, the switch is closed. Okay, then we say now it is going on for a long time. So capacitor will be open circuit. All I need to calculate is what is the voltage at this point if I consider here is ground. Okay,
yes.
now calculate what is the voltage at this point.
Sir, we can find current and then there are two paths we can calculate it.
So we have to find from first step and then do the integration.
You can consider this is V. Okay, then KCL at V, one current is this side, that is V minus 10,
V minus minus 10.
Y minus 10, this is plus 10,
Sorry, plus 10.
and then V minus minus 50, that means V plus 50 by 6 equal to 0. That means 3V minus 30 plus V plus 50 equal to 0. That means 4V equal to minus 20. So V is equal to minus 5. Is this okay?
Yes, sir.
So the final value is minus 5. So my equation will be final value plus initial minus final 10 minus minus 5 15 e raised to power minus t by tau. And finally, what is the value of tau?
1 by 2.
1 by 2. How?
So we calculate the resistance, which is if we just short these voltages and
Okay.
open circuit the capacitance, the two resistance will be in parallel.
Okay.
उससे तो
And
3 आ रहा है.
So sir, resistance will be 3 by 2 and 3 by 2 into 1 by 3 is 1 by 2.
okay, fine. So to calculate the equivalent resistance, that is same as Thevenin resistance. Okay. How did we calculate Thevenin resistance? By making independent sources 0. So both these voltage sources will be made short circuit. 2 ohm and 6 ohm, they are parallel to the capacitor. 2 ohm and 6 ohm will give me 3 by 2. 3 by 2 into 1 by 3 means 1 by 2. That is the value of tau. Is it clear to everyone now? Any
Yes, sir.
issues? Okay, fine. So now, similar question. Very quickly, please calculate V initial, V final, and tau.
V initial 10.
Okay, I am writing here.
So V initial 0.
V initial 0 or 10.
So V final 20.
V final 20.
Sir, sorry, it's not 0. It's 10 only.
So initially what is happening, initially this is attached like this, okay? And this is 30 UT, that means at t less than 0, this is 0 volt, okay? So voltage across this, it is parallel to voltage source. So this will be same as this voltage source. So this will be 10. And after that I am saying I am removing this, this is gone, and this will be 30. 30 will be divided into 10 and 20. So voltage across, final voltage across this capacitor will be 20. This is fine. Now what is the value of tau or R?
So 1.67.
What will be effective R? R will be 10 parallel 20. Is that okay?
Yes, sir.
And into C, that means 1 by 4. Okay.
5 by 3.
Hmm?
Sir, 5 by 3 down.
Okay. Now, this is voltage. Voltage equation you got for every time. Voltage equation is V final plus V initial minus V final. That means minus 10 e raised to power minus t by tau. What about this current?
Sir, can you explain V initial once more, please? I'm little bit getting confused.
This switch is closed. Okay. Something is parallel to a 10 volt source. So what will be the voltage across that?
10.
Okay.
But isn't it influenced, like there is no switch at left hand side, so isn't it be influenced by that?
What will happen?
Like, yeah, okay, sir, okay.
Before t equal to 0, this is short circuit. Okay. 10 ohm, 20 ohm capacitor and 10 volt. Everything is in parallel.
Okay, sir, got it.
Okay, now I have obtained the expression of voltage for every time. What about this current? What
Sir,
is the
can
value?
we use
Yes.
this? Sir, can we use the same equation for I? Means first we find the I at infinity, then I at 0, and by solving by the same equation as we done V naught and V infinity.
This current is a current in resistor. Okay, which is not the voltage across capacitor. So
Okay.
this current will always be obtained by other parameters and it can change immediately abruptly.
Okay, sir. But sir, in question, if they asked to find the current in capacitor, then we can do that method.
No, only the voltage across capacitor is going to be governed by those equations. Okay,
Okay.
because
Okay, sir.
current in capacitor is IC dV by dt and differential can change abruptly.
Okay,
So
sir.
first you need to calculate voltage, then differentiate that, you get current.
Okay, sir.
Okay, now coming to this question, what is the value of this current for t less than 0?
Sir, 1 ampere.
1 or minus 1?
Sir, -1. Right.
Okay,
Yes, sir.
the quizzes will not accept sign mistakes. Okay, so be very careful when you are answering. What are we saying? 10 ohm, 20 ohm capacitor and voltage source, all of them are parallel. So what is this current? This current is 0 minus 10 by 10. That means minus 1 milliampere. Okay. Oh, sorry, ampere. This is ohm only, not kilo ohm. So minus 1. After that, for t greater than 0, what will be this current value?
Sir, +1.
Plus 1. Why?
Sir, for t greater than 0, no?
For t greater than 0.
Yes, sir. The current will flow in this circuit only. Okay, sir. Okay. No, sir. No, sir. The capacitor will also come to play after
Capacitor
that.
will
After
also
a
be
long
there.
time. Yes, sir. Yes, sir. Yes, sir.
So this is the total current. Some current is going here, some current is going here, and 30 volt source is attached. What is the total current? Yes, anyone? How do you calculate that? Can I say that this total current is summation of these two currents? What is the current in capacitor? C dV by dt. I already got the equation of V. And what is the current in 20 ohm? That is V by 20. So this current plus this current is equal to total I. Is that okay? Is it okay for everyone?
No.
Sir, can
Yes.
you
Yes, sir.
explain the -1 part? How the -1 came?
Yes, sir.
Minus
How,
one.
-1.
how -1? Okay, this is the circuit. This is short circuit and this is attached like this. So this 10 ohm is basically here. And I am asking what is this current? This is 10 volt, this is 10 volt, this is 10 volt, this is 10 volt. So if this is 10 volt and this is 0 volt, what is this current?
Okay, sir. Okay.
Okay.
Yes, sir. It will be 100.
Now, first of all, when we are talking about R infinity, that is 20 ohm, and R Thevenin will be 20 parallel 10, and tau will be 5 by 3. These are the things we calculated. Once I have this, then I get the equation of voltage across capacitor also. That is V final plus V initial minus V final e raised to power minus t by tau. Now coming to the total current. Total current is the, look, current in this branch plus current in this branch. Current in the first branch is V by 20. Current in the second branch is C dV by dt. Okay, V by 20 plus C dV by dt. What is the value of V? V is this expression, this complete expression. Okay, so when you do V by 20, you get this, and when you do C dV by dt, you get this. Add all of them, you get this. Is this fine now?
Sir, can you please show the previous slide once? Yes, sir, it's fine.
If I ask you what will be the final value of I, can you calculate that at t equal to infinity? Looking at this circuit.
Volunteer.
Only across resistor.
One.
Finally, what will happen? Finally, no current will go here. Okay. Finally, no current will go here. It will only go here, and that will be 30 by 30. That means 1.
One more.
Look
One
at
ampere.
this equation. If t is equal to infinity, e raised to power minus infinity is 0, and finally it will be 1. Okay. These are the things you can cross check when you get your answers. This is a practice problem. It will be given in the slides. You can practice it. Answers are also given. It's a very similar question that we have done right now. Okay. Coming to the circuits when inductors are involved, nothing is different. Only thing you have to focus on is first calculate inductor current. Everything else later. And again, calculation of inductor current will be done in the same way. That means total current is final value plus initial minus final into e raised to power minus t by tau. Okay, No difference, exactly same. We are just doing the same derivation again. If I take KVL, I write the KVL equation, I solve it, take those, okay? We are doing the same thing, and finally we will have the same I final plus initial minus final into e raised to power minus t by tau is the inductor current at any given time. Once you get this, later you can calculate other quantities. Is this clear? Okay.
Yes, sir.
Yes.
Now let us look at this question. We are saying this switch is initially closed. If it is closed, that means this is not in the picture and it is valid for a long time. Inductor is short circuit. So what is the current in inductor?
5.
5 ampere.
I naught is 5. What is I final? I final means now this is open. Now this is open. So 3 ampere, 3 ohm will be in the picture, but
I
inductor will be short circuit again. So I final will be
2
2
after a
ampere.
long time of
2 ampere.
opening.
It will be 2. Is that okay?
Yes, sir.
And what is tau? L by R. L is 1 by 3. What is effective R?
5.
That is 5. Okay. So that means 1 by 15. So what is my equation of current in inductor? V final plus initial minus final into e raised to power minus t by tau. Is this fine?
Sir, can you please once again explain the I final to?
I final means, let me clean it. I final means consider the DC condition at t equal to infinity. Okay, t equal to infinity means this is not there. 2 ohm, 5 ohm series with a short circuit inductor, because in DC condition inductor will again act like short circuit. So what is the current flowing in inductor now?
2 ampere.
Okay.
Yes,
So
sir.
initial value we obtained 5 ampere, final value we obtained 2 ampere, we obtained the value of tau 1 by 15 and we got the complete expression. Did I make any mistake? Here I have put the minus sign, it should have been plus. Okay. Once you know the inductor current, then you can calculate any other thing if we ask. This is also a very similar question. Now tell me, what is the initial value of current and what is the final value of current? To calculate the initial value, this is closed. That means no consideration. This is short circuit. This is 3 ampere going here and here. So how much is the initial value?
3.
3.
3.
3.
What is the final value? Final means this is open. So some current is going here, some current is going here.
2.
Final will be 2.
2.
And remaining things you can calculate. Okay. So V final is 2. Initial minus final is 1 and e raised to power. Okay. So now you have this. Start working on this. This is our last question for today. You can start working on this one.
Sir, in the last question, isn't it be 2 and 1 when like before I naught and when t less than 0, it will be like 5 and 10, then 2
5
ampere
is
will.
not there. For t less than 0, 5 is not there because
Oh,
this switch is closed.
yeah.
Okay.
And for final, okay, okay. तो फिर वहाँ से हाँ ठीक है.
Please read this very carefully. Okay, so let us start verifying some of the answers. At t equal to 0 minus, what is the inductor current?
0.
0.
0.
0.
0. 0.
Okay, because both the sources were open, right? So
Yes,
we
sir.
are at
Yes, sir.
10:58. I am going to very quickly go through the solution. So first of all, if you see at t equal to 0, this is open, this source is not attached, this is not attached. So I equal to 0 plus or 0 minus, the current is 0. Okay. Now look, from 0 to 4, only this one is attached. And because of this much part is still not into our circuit, this current will start increasing. And I don't worry whether this circuit is part of my life or not. Don't even consider this, and consider that at infinity, what will be the value of this I only because of this? What will be that value? That is coming to
4
be
ampere.
4. Okay.
4
And
ampere.
4.
what is the
4.
R-Thevenin? 4 plus 6, 10. What is tau? 1 by 2. That means the equation of I is V final minus e raised to power minus t by tau. Is this okay? This is the equation for lifetime if I don't consider the central branch. Is that okay to everyone?
Sir,
Sir, are we
10.
not supposed
Sir,
to
it should be
calculate
4.
everything?
4, sir.
Right. Should be 4, sir.
4, right. 4, not 10, 4. 4 minus 4. Okay.
Sir, why we are not considering the central branch?
Please listen. Something will come into future. Why do you consider that? When it will come, then we will consider, right? Now we are saying for lifetime, this will be my equation. But lifetime is not very long. It was only 4 seconds. After 4 seconds, what I say, I am attaching one more circuit. So I said, okay, I don't worry. According to this equation, if I put t equal to 4, what is the current I am getting? Okay. So this equation which I got is although valid for lifetime, but I said at 4 I am doing something else. So at 4 I put t equal to 4 here, and I calculated it was coming 3.997 something. I said it is almost 4. So that means uh, the current at I equal to 4 minus will be current at I equal to 4 plus. But after that, a new equation will form. Now what is happening after t equal to 4? This is closed, this is closed. And till infinity, this circuit will work. Now calculate what will be I infinity with this arrangement. With this arrangement, when I calculate I infinity, I apply KCL at those points and I calculated that I infinity is 2.7. Okay. Considering the same circuit, I also calculate resistance across this inductor. This is short circuit, this is short circuit. 4 and 2 parallel series with 6. 4 and 2 parallel series with 6, that is 22 by 3. So my new value of tau is 15 by 22. So what is my current equation for the remaining life? That is final value 2.7 plus initial minus final 4 minus 2.7 into e raised to power minus t minus 4 by tau. And what is tau? 15 by 22. Is this okay now?
Sir, cannot we apply like parallel batteries concept, like equivalent battery and
What are they? These batteries are not in parallel.
like 40 and 10 and respective their resistances?
40 and 10, they are not in parallel. What is the condition for some things to be in parallel? These two terminals, they should be same as these two. Are they same?
If you consider 4 ohm resistance and 2 ohm resistance as their internal, then
Why
can
do you
we?
consider that? Then you can consider 6 ohm also internal, then there is no resistance in the whole circuit.
Okay, sir.
Okay, so now what we are saying, please look at the slides also, that V final plus V initial minus V final e raised to power minus t by tau. Instead of t, it will be t minus 4 by tau. And when we put these values here, tau is equal to 15 by 22. This is the equation of current for t greater than 0. Okay, so when I put the complete value of I, it was 0 for t less than 0. It was this equation for t 0 to 4, and it is this equation for t greater than 4. And after that, we are asking that from at t equal to 2, what is the value? T equal to 5, what is the value? So if it is t equal to 2, I will take this equation. If it is t equal to 5, I am going to take this equation. Is it okay to everyone now?
Yes, sir.
Yes,
So
sir.
what is happening to the inductor current? Inductor current will slowly rise to 4 at 4 seconds, and it will slowly settle to 2.7 at infinity. Is it okay?
Yes, sir.
So tomorrow we will start with second order circuits. We will share some more practice questions, and if you get roll numbers, we'll share your practice quiz also. Okay.
Bye, sir.
Okay then
Okay,
everyone.
sir. Bye, sir.
Thank you.
Thank you, sir.